Welcome to our lesson on compound events. Compound events are part of probability, and it's when we have two or more events happening at once. So we have two types of them. They are independent and dependent. So previously we've been doing our keyword as or, and we're going to add two new keywords to that for today. So or told us to add, and now we are going to do multiplying. So when you see the word and, or if you see the word then, that means we are now going to be multiplying. So under our two types we have independent, so those are when the outcome of one event does not affect the outcome of the other event. So they are totally independent, they don't affect each other at all. So we also have the keyword and here. When we calculate the probability of two events happening, we are going to multiply them. So the probability of A multiplied by the probability of B. And dependent is going to work just like independent, but it's just going to change the second event. So that is because when the outcome of one event does affect the outcome of the other event. So this is like conditional probability, like we did in our last lesson. So just like conditional, we have the word and again, so we know it's still multiplying, just like this one, but the probability of A, and this event is going to be affected by A. So it's going to be the probability of B after A occurred. Or given A. Let's look at a few examples of independent and dependent. So we're going to do the left side, and then you will do the right side. So on the left side, our first one says, a die is rolled 3 times. What is the probability of getting ones on each roll? So it's happening 3 times that I'm going to roll a die. So I know that I'm going to be having 3 probabilities. 1, 2, 3. Kind of how we did the fundamental counting principle, but this time we're dealing with probabilities. So getting a 1. The probability of getting a 1 we know is 1 out of 6. So this would be the first roll, this would be the second roll, and this would be the third. So each of them has a probability of getting 1 out of 6 to get 1. And the probabilities are independent because each roll does not affect the other roll. When we multiply fractions, we multiply across the top and across the bottom. So 1 times 1 times 1 is 1, and 6 times 6 times 6, if you calculate it out, is 216. So a 1 out of 216 chance of getting a 1 on all 3 rolls. Now let's take a look at our other examples here. So a bag has 8 red crayons, 14 purples, 6 yellows, and 4 greens. A crayon is selected, replaced, so put back in the bag, and then another is selected. Find each probability. So the first thing we're going to need to know is how many total crayons are there? Well, 8 plus 14 is 22. 22 plus 6 is 28. And 28 plus 4 is 32. So 32 crayons total. So I want to find the probability of purple, then yellow. We know that then means multiply. So I have 2 events happening, the probability of purple and the probability of yellow. So my first event is purple. So there are 14 purples, and that is out of 32 crayons. So that's the probability of purple. Now I put the crayon back in the bag, so there's 32 in the bag still. And this time I want to see what's the chance of picking up a yellow. So this is out of 32 because I replaced the crayon back in the bag. And yellow has 6 crayons. So 6 out of 32. Now you have options. You can multiply across the tops and the bottoms and then simplify it, You can put it in your calculator. You can also do some simplifying of the numbers. So both of these are even. So if I divide them by 2, 7 out of 16. And same over here, they're both even. So 3 out of 16. And when I multiply, 7 times 3 makes 21. And 16 times 16 makes 256. So the probability is 21 out of 256. You could also put it as a decimal, but it's easier just to leave it as a fraction. All right, let's see the last part of the independent. So probability of 2 purples. That means I'm picking 2 crayons. So I still have 2 blanks here. So my first one is purple. Again, it was 14 out of 32. There are 32 crayons in there. We're starting again. And the probability of getting a purple is 14 out of 32. Then we replace the crayon. So for the second choice, there's still 32 crayons. And it was 2 purples, so I want purple again. And I put the crayon back, so there's still 14. Now I'll multiply these. So I can again just multiply across and then simplify, or I can simplify before. And I can put it in my calculator too. But these are both even, so that's 7 out of 16 if I divide them by 2. And this is the same. So 7 out of 16. 7 times 7 is 49. And 16 times 16 is 256. All right, and the last section is the dependent events. So remember, this is just like conditional probability, where the probability of one of the events is affected by the other one. So using the same example above, so we've got the same crayons, assume once a crayon is selected, it is not replaced. This is important. Not replaced. That means that after you take out the first crayon, there's one less crayon than there was before. So this time we're going to find the probability of yellow and then red. So we have 2 crayons that we're picking. So the first one, let's put that one first, yellow. So the probability of yellow, well, there's 32 crayons in the bag. And the probability of a yellow, there are 6 yellows. So 6 out of 32. Then red. Okay. The crayon was not replaced. So now, instead of out of 32, it's out of 31. Okay. So we lost 1 crayon, if you want to make a note. And that crayon was yellow. So the red crayons, there are 8. So inside of the bag, there are 8 red crayons out of 31. So now let's multiply this out. So you can put it into your calculator, or you can multiply across and then simplify. It is up to you. So these are both even. So I divide by 2, I get 3 out of 16. I can't simplify these, so I can do 3 times 8 is 24, and then I can multiply these and simplify, or I know that 8 can divide into 16, so 8 divided by 8 is 1, and 16 divided by 8 is 2. So 3 times 1, and 2 times 31 is 62. And if you are having trouble with that, you can use your calculator to help you to multiply these out. So let's go down to one more with the crayons. This time we want 2 reds. So we have 2 crayons that we're taking. Okay. The first one, so we'll do the first crayon. We want 2 reds in a row. So we know there are 32 crayons in the bag when we start, and the reds, there were 8. So I have 8 out of 32 for the first one. Now when I go to my second one, this one is out of 31 because it was not replaced. And this time we lost 1 red crayon. So there are not 8 crayons in there anymore that are red. There are only 7 reds. And that's because we wanted 2 reds. So now we are just going to see if we can simplify this a little bit. So 8 over 32, they're both divisible by 8, so 1 over this divided by 8 is 4. 1 times 7 is 7, and 4 times 31 is 124. And last example, a card is drawn from a standard deck, not replaced, and another is drawn. What is the probability of choosing a heart and then a spade? So we have 2 cards that we're picking. So the first one is heart. So we know that there are 52 cards in a deck, and hearts make up a quarter of them. So 13 cards are hearts out of 52. This is the probability of heart. And then it is not replaced, so my next one only has 51 cards. Then a spade. So my probability of getting a spade now, well, there are also the same amount of spades as hearts. So there are 13 spades out of the 51 cards that are left. And if we multiply this together, we could simplify a little bit. 13 over 52, they're both divisible by 13. That's 1 out of 4. So 1 times 13 makes 13, and 4 times 51 makes 204. And you can also put this into your calculator. All right, go ahead and try the other side and see how you do. Thanks.